in the last one we have discussed what are matrices and what were the types of the matrices. Okay, so we'll have all the types of matrices. See, this is the table. So we have discussed in the last one, right? All the matrix like nilpotent, idempotent, involutory, symmetric and skew symmetric we are going to discuss in today's session, and orthogonal. This we have already discussed. So what is important here? You can keep this as a like quick note. Okay, like what is the condition for that? So kindly excuse me, we'll turn it on. Yeah, sure, not an issue. Okay. So these are the types of matrices. So what you have to like take a note of, like these are the conditions. So in front of every matrix, there's a proper designated condition written for that. So suppose you're talking about idempotent matrix. So yes, A square is equals to A. Involutory, A square is equals to I. And symmetric and skew symmetric, we'll have a discussion on that. Orthogonal, A into A transpose must be equals to I. So these are the conditions. Okay. Fine. So we can start with today's lecture. So in this lecture, what we are going to cover? We are going to cover some extra operations on matrices, followed by multiplication also. And we'll learn about symmetric and skew symmetric and so and so. Okay. Okay. So first of all, matrix, see in the multiplication of matrices, there are two types of multiplication. The first one is scalar multiplication and the second one is matrix multiplication. So scalar, which means you are multiplying a matrix by a single number, and matrix multiplication means you are multiplying both the matrices. Like if I have a matrix A, like this 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have to multiply it by 5. Like I want to find the value of 5A. So what is going to be the answer? So you just have to multiply that number, like 5 is going to be the scalar one over here. Okay, so in scalar multiplication, what we usually do, we just multiply this 5 with whole matrix. Whole matrix means this 5 has to be multiplied by each and every element of matrix A. So every element will be multiplied, will get multiplied by 5, and the answer will be the product matrix. So what will be the value of 5A? So it will be 5, then 10, then 15, and so on, so on. So can I switch my cam on after 10 minutes, sir? And excuse me, sir. Thank you. Fine, that's not an issue. Sorry for joining late, sir. I had some tech issues with the dashboard. That's okay. That's good that you have joined. Nothing is skipped right now. Fine. So this is the first topic that we are discussing. Okay. So as you guys know, like 5 is to be get multiplied by each and every number. Okay. So this will be 35 and 40 and then 45, like this. So this is the answer. So it is very simple. Like what do we do in scalar multiplication? Whatever the number you are trying to multiply it with a matrix, just multiply each and every element by that number. I hope the concept is clear. Okay, see, K is the scalar over here. So what we are going to do? We are going to multiply this K with each and every element of matrix. So earlier we had a matrix in that Aij m cross n was the order. Okay, m cross, see there is nothing related to the order, because whatever order the matrix is having, scalar multiplication does not care about order, but the order will be remain same. Like if 2 cross 2 matrix is there, then the product matrix will be also 2 cross 2 in case of scalars. Is there any confusion? Is there any problem? No. Fine. We got some very interesting questions in this session. Okay, so you have to like take care of each and every basic detail. Then we'll be solving some questions which are directly from JEE Mains. Okay, so here is the first problem. K is equals to 2 and A is equals to this. Like this matrix is given to you, and you have to multiply it by, like you have to find Ka, or I can say 2A you have to find. Again, not an issue. What I've told you that you have to multiply each and every element by that number. So it will be 6. The second element is 2. So it will be 4 because you have to multiply it by 2. Then it is minus 1. So it will be minus 2. Then it is 4. So it will be 8. Then it is minus 3. It will be minus 6. 1. It will be 2. Is that clear? It's a very easy thing. Like according to me, this topic should not be in class 12. But yes, because this is in class 12, so that is why it is the most important, most easiest topic entire maths. Okay, so matrices and determinants are something which are very, very, very easy. So everyone has a good hold on matrices and determinants, because there are some students like that also. There is this case also that the students know only matrices and determinants. The rest of the things they don't have any idea about. But that's not an issue. Okay. See what I've done. Sub multiplied it by 2. Again, the answer is not written in this slide, so I'll write it. The same answer that we have discussed in the previous slide. So 6, 4 minus 2 and 8 minus 6 and 2. So this is going to be the answer. Okay. So multiplication of two matrices, I think this is the most important concept for the day, because multiplication will help you in like each and every question of matrices. So because there is something which is directly involved to multiplication of matrices. So it is very important to know the multiplication. So what are the rules of multiplication? How it is going to be done? Okay, how do we perform multiplication? So that is why we have here multiplication of two matrices, so that each one of you has a clarity of multiplication. There might be some students that have an idea about how to multiply matrices, and I also discussed this in like rough manner in the previous term, right? But yes, we can now see it in a proper way. So multiplication of two matrices. So it is very important to know, like before you multiply two matrices, it is very important to know that you have to check whether the multiplication is possible or not. Like you just can't give me two matrices and I will multiply, right? This is not the proper way. So what is the proper way? You have to first check whether the multiplication is possible or not. So there is a condition that needs to be fulfilled prior multiplication. Okay, so there is this condition that I'll be telling you. So what is this condition? Suppose A matrix is there and the order is m cross n. And suppose B matrix is there, not this equal to sign. Yeah. And suppose B matrix is there and this is having its order as n cross r. Okay. So you have to check of these two numbers. Okay. Or what are these numbers? It is exactly number of columns in M1. What do you mean by M1? M1 is matrix 1. And you have to check for number of rows in M2. So if these two numbers are equal, then only multiplication is possible. So if these two numbers are equal, then only multiplication is possible, else not. If the number of columns in matrix 1 does not matches with the number of rows in matrix 2, multiplication is not possible. In that case, you are not supposed to multiply the matrices. Okay. So this is the condition that is clear. Okay, so we'll see to it like how we are going to proceed. So this is the condition that I've told you, that number of columns, again there's a misprint, number of columns in matrix A should be equal to number of rows. Okay. Fine. This is the condition, so the condition is clear to you. Now, after checking like whether the multiplication is possible or not, you have to find, see if it is not possible, then obviously you don't have to do anything. But if it is possible, then there is also one thing which is to be done before multiplication. That is, you have to find the order of the new matrix. What will be the new matrix? Obviously the product matrix. Like if I have considered this A and B, so the AB will be my product matrix, right? So this AB will be my product matrix. So before finding AB, we have to find the order of AB. Okay. So order of AB will be what? it will be M cross R. Like two numbers you were looking at, like these numbers must be equal. So the two numbers that you have left, that is number of rows in M1. Okay, what is this M? See the okay, I'll write in the next slide. Okay, we can see here also, like A matrix we are having, I've considered one example. So 2 cross 3 is the order, and the B matrix 3 cross 4 is the order. So I can see that 3 is equal to 3, right? So now AB is possible. The multiplication of AB is possible. Now what should be the order of AB? So order is always this 2 and this 4. 2 cross 4, yes. So order is what? Order is number of rows in the, like the terms that you have skipped. Number of rows in matrix 1 multiplied by number of columns in matrix 2. I should write this also. Number of rows in M1 cross number of columns in M2. So this is what? This will give you the order of product matrix. Okay. So everybody please note that. While I have a few words with like the students already present over here. Okay, so Kyle and this one is Sustitha. Very typical name, Sustitha. Yes. Please turn on your cameras. Yes. So you're not supposed to turn off your cameras, okay? So get that thing, because it is very practical and logical. Like I am not having any idea like what is going on beyond, behind the screen. Yes or no? So I can see a blank screen over here. Okay. So somebody has joined the session and there is this black screen. Like mic is also turned off, camera is also turned off. So there is no point. So if I am going to see such kind of faces or such kind of like participants, I'll simply remove that. Okay, I have that power. I can remove the participants also. Yeah, I don't want to, but yes, you guys are like making me to do that. Okay. And try to communicate as much as possible. Like if you are not okay with the voice, then you can also put messages into chat also. Okay. So Kyle and Sai is also there, which is the camera is not turned on, and Sustita and Jyotsna has her reasons. That's not an issue. Fine. So you guys are like good to go till here. The condition is clear, and condition is if condition passes, then what is the order? That is also clear. So what is the order in that case? Yazra has answered it correctly. 2 cross 4. So 2 cross 4 is going to be the order. Now once you know the order of matrix, you can easily like you can have a rough idea of that matrix in your mind. Like how will a 2 cross 4 matrix look like? So it will be having 2 rows and 4 columns. So it will be like this one, A11, okay, A12, A13, A14, and A21, A22, A23, A24. This is going to be the matrix, like the product matrix will look like this matrix. Okay, so you have to do this thing. Why you have to do this thing? Because it is very easy to solve now. Like if you are doing the calculations now, so you are doing the calculations in your mind, and if you are doing it in your mind, that means you are not writing, so it is your dynamic memory. And if it is in your dynamic memory, you will easily skip, you will easily like commit mistakes. So what I can suggest is, see, this is a very lengthy process, to be very honest. Okay, yeah, but I do have tricks for adjoint and inverse and so on. I have that tricks also, but I'll share with you also. But for multiplication, there is no trick involved. So we have to accept the fact that it is a typical lengthy process. So why to like waste our time and also getting the wrong answer? right? So you are doing it for once, do it properly, with the proper concentration, with the proper presence of mind. So I better suggest you how to do that. You just have to frame a matrix like this and just put random elements in it. Like A11 is there, A12 will be there, A13 will be there, A14 will be there. Now, see, if I am asking a particular element of the product matrix now, then please keep that thing in your mind that you don't have to find the entire matrix. Because according to the common sense also, if I am asking A23, then you can separately find A23 now. Why you have to waste? Okay, why to waste time? Got my point? There are some questions, and you guys are in the habit of like under pressure, right? So you are just reading the question. Okay, so C matrix is there. You have to find the value of C, and then you have to find the A23 of C matrix. So just directly find A23. There is no need to find the entire C matrix. Fine. Okay. Okay. And please ignore whatever the thing is written on the slide, because my typing department is like not that much. They don't have that much of technical knowledge, no? So that is why they are like committing mistakes. So number of columns again here, and number of rows. Okay. Yes. So again, this is 2 cross 3 and this is 3 cross 4. So we know that the order is going to be 2 cross 4. Fine. Now how to perform multiplication? The very important. Okay. See, this is the proper method of performing multiplication, but I am sure that you are not good with this, such kind of expressions written in such kind of manner, right? So I'll explain it. Okay, fine. I'll do that explanation over here also. So I'll just write down the matrix. Okay, so AV I am talking about. So I've discussed that AV will be having how many rows and how many columns? 2 rows and 4 columns. So according to that, A11 is here, A12 is here, A13 is here, A14 is here, and A21 is here, A22 is here, A23 is here, A24 is here. Yes. Now I'll find each and every element. Like first element is my A11. So how I'm going to do that? A11. Okay. So if I talk about A11 now, so that means there are two numbers. Okay. So 11 means, see, this number is always on left side. This number is on right side. So left represents your matrix 1, right represents your matrix 2. Again, left represent your row and right represent your column. Okay. So A11 means I have to pick the first row from the matrix 1 and the first column from the matrix 2. So first row will be this 1, 2, 3. First column will be this 1, 2, 1. So what I'm going to do is I have to multiply the corresponding elements and then add them. Like 1 is here, 1 is here. So I'll write 1 into 1. Again, second is 2, second is 2. So 2 into 2. Third is 3, but third here is 1. So 3 into 1. And then I'll add. So 1 into 1 will be 1, 2 into 2 will be 4, 3 into 1 will be 3, 1 plus 4 plus 3, that is 8. So A11 is 8. So you guys have to perform the multiplication and find the value of each and every element. Go. Just find product matrix AB and let me know the answer. Like I'll be asking questions to you. Like I'll ask what is the value of A22. Okay, then you have to answer it and then I'll check like whether you have evaluated the correct value or not. Okay, so 2 minutes time to you and solve this question. Let me know. Yeah, Azra has done. Good. Rest of the participants, please. Done. Okay. So, Adil, you tell me, arey, you don't have to like write down the answer because everyone now can see now. Like 8, 11, 17 and 8. First row. 8 is correct because 8 is the same answer that I have got also. So what is the value for A12? Okay, we'll check size answer. Like A12 will be finding out. What is A12? A12 is first row and second column, na? So 1 into 2, that is 2, plus 2 into 0, that is 0 only. 3 into 3, that is 9. So 9 plus 2 is 11. So yes, second one is 11. So I'm sure you all of you have got the right answer. So we can skip this. Yes. So is anybody is here having some issues with the multiplication of matrix? No. Okay. Okay. See. So these are some of the properties of matrices that you have to take a note of. Okay, just note down. Matrices A, B, and C are conformable if A multiplied by B plus C is AB plus AC. So this is a condition. Okay, that will be executed in case of matrix multiplication. This is also a condition. This is also a condition. Like if there are three matrices like A, B, and C, so you can first multiply B and C and then multiply the entire product with A. The answer will be same as you do in the case you multiply A and B first and then multiply the entire with C. Okay. And in general, AB is not equals to BA. Please, these are A and B are not the numbers now. These are the matrices. So when you like reverse the order now, like AB and BA, then there is sometimes this possibility also that the multiplication is not possible. For example, like in this case, C. In this case, we are having the order of A to be 2 cross 3. Okay, and the order of B will be 3 cross 4. Yes. Suppose I have to find BA. So BA, I'll check 4 and check 2. So 4 is not equals to 2. So BA is not possible. At this point, in this case, BA is not possible. But yes, AB is possible. And we have calculated AB also. So this thing is very important that you have to take care of. Okay. And AB is equals to 0. Not necessarily imply A is equals to 0 or B is equals to 0. See. If AB is equals to 0, that never means that entire matrix is 0. Okay, there might be some possibility that there will be some elements that are like negative elements are added and the element is 0. Okay. And also if AB is equals to AC, there is no such necessity that B is equals to C. So please note this down, guys. Okay. Just give me a thumbs up if you have done copying.
Start ball. Dot ball 0 run.
Yes? Fine. Okay. So transpose of a matrix. This thing is also we have done in the previous session. Like what is the transpose of a matrix? What do we do in transpose of a matrix? We just simply interchange rows and columns of a matrix. while taking a transpose, and it is represented by AT or also represented by A dash. Okay, so when rows and columns are interchanged in a matrix, then the product is said to be transpose of a matrix. So why we are again recalling it? Because in today's session we will be discussing some types of matrices which are directly based on transpose and multiplication. Okay. So matrix obtained by interchanging the rows of A into columns is called the transpose of A. Yes. Fine. Symmetric matrix. Very important discussion. Please guys, you have to note this down also. So suppose if I'm having a matrix, okay, suppose A matrix is there. Okay, I'll write down the condition. What do you mean by symmetric matrix? If Aij is equal to Abi, if Aij is equal to Aj, then the matrix is said to be symmetric. Now suppose, see, I and j must be two distinct numbers, na? Like A11 is A11 already. If you just interchange the j and I. So we will not talk about A11, A22 and A33. We will not talk about A11, A22, A33. We will talk about A12. And if A12 is there, then I want to check A21. If this is equal, provided suppose A23 is there, and then I'll check A32 also. And suppose A12, 21, 23, 32, and A13 is there, so A31 I'll check. Okay. So if this condition is executed successfully, then the matrix is said to be symmetric matrix. Okay, so final condition is this, but what we have to check is this. So we have to check this, and the condition is this. So it is not valid for only one pair. It has to be valid for each and every pair. Like A12 and 21 should be there, A23 and 32 should be there, A13 and 31 should be there. Okay, just note it down. So this is the condition for symmetric matrix. Okay, so in other words, like in terms of definition, what we can do, we can check like if a square matrix is there, so we can find the transpose first. Obviously, we know how to find the transpose. Okay, obviously we know how to find the transpose of a matrix, so we can directly find the transpose, and if that transpose is equal to A, then the matrix is said to be symmetric. So eventually, this is the only condition that I am talking about. Okay, suppose, so we have to check, for example, we are having this matrix. Now, it is symmetric or not. See, so I'll not talk about 1, -3 and 4 because their positions are A11, A22 and A33. Perhaps I'll check for 2. So A12 is what? 2. So again I'll check A21. A21 is what? Oh, it is also 2. So that means yes, one pair is there. That doesn't make the whole matrix to be symmetric. Okay, if there is only one pair, that doesn't mean the whole matrix is symmetric. You have to check each and every pair. So now I'll check this A13. So A13 is 0 and A31 is also 0, we can see. Yes. Now I'll check A23. So A23 is what? Second row and third column, -1. So A32 is what? It is also -1. See, we have each and every pair which is equal. So now I can say that yes, this matrix is a symmetric matrix. Okay. Why this matrix is symmetric? Because we have each and every pair equal. So this is completely satisfying this condition. Aij is equals to Aj. Take a note of this. See, so that we have shown it in this slide also. Like the highlighted elements. Just look at the highlighted elements. A12 is equals to A21. You can see that 2 is 2. And then again A23 is again equal to A32. Then A13 is equals to A31. 0 and 0. So therefore A is symmetric. Yes or no? Yes. So what are properties of symmetric matrix? See, again very important discussion. If A is a square matrix, then A plus A transpose as well as A into A transpose are always going to be a symmetric matrix. These are the properties that we are going to use on directly questions. Okay, so these are the certain key points which you have to like by heart. Okay, like if A is a symmetric matrix, then A plus A transpose will always be a symmetric matrix. So A plus A transpose will also be a symmetric, and A into A transpose will also be a symmetric. Okay. The zero matrix, diagonal matrix, and the unit matrix are symmetric. Obviously, the zero matrix is what? 0, 0, 0, 0, 0, 0, 0, 0, 0. The diagonal matrix is what? Something which is having elements in its diagonal only. So 1, 4, 2. Rest all the element is 0, 0, 0, 0, 0, 0. And this unit matrix. Unit matrix is 1, 1, 1, 0, 0, 0, 0, 0, 0. Now, if you look carefully, then there are only, see, if we talk about diagonal matrix. So, this is A11, this is A22, this is A33. That we don't have to look also, no? That we don't have to look also. So, if you pick any element, it is obviously equal to 0. Same goes in this case. If you pick any element except the elements in diagonal, then you are going to get the same answer, that is supposed to be 0. And here each and every element is 0. So, that is why zero matrix, diagonal matrix and unit matrix are symmetric. Next property. If A is symmetric, then A raised to the power n is also symmetric for all n belongs to natural number. This sign is known as for all. Okay. So A raised to the power n will be also symmetric. So if A is symmetric, then A square will be symmetric, A cube will be symmetric, A raised to the power 4 will be symmetric, and so on, so on, so on. Okay. Next property is if A is symmetric, then Ka is also symmetric, where K is scalar. Same thing. Like if you multiply any element with the number, okay, like any element with the number is multiplied, then that particular matrix will also be symmetric if the previous matrix is symmetric. So that is also a very common point to understand. Okay, fine. Now we have skew symmetric matrix. What is a skew symmetric matrix? Just note down the condition. If Aij is equals to minus of Aji. Okay. So if Aij is equals to minus of Aji, then the particular matrix is said to be skew symmetric. So I'm not looking for like Aij and Aji must be equal, but yes, they should be like equal to negative of each other. Okay, so we'll look one example also. Suppose this is the matrix A. Again, I don't have to look for A11, A22 and A33. I'll look for A12. So what is A12? It is 2. So now I'll look for A21. A21 is, it is minus 2. So I can say that yes, that property holds on this pair. Like Aij is equals to minus of Aji. Yes? Yes, that property holds. So in the same fashion, we'll be checking off A13. So A13 is what? 4. So A31 is third row first column. This should be minus 4. Okay. This is minus 4. Wait. Yes. So it is minus 4. So yes, that property also hold on this pair. And then we will check A23, which is equal to what? Second row third column is 1 and 32 is minus 1. So it is 1 and A32 is minus 1. So yes. So that means entire Aij is equals to minus Aj. That means this matrix is skew symmetric. So please note down. Okay. See again, we can see that A12 is equals to minus A21. Similarly, A23 is equals to minus A32. And similarly, A31 is equals to minus A13. Okay. So now what are the properties for skew symmetric? The zero matrix is skew symmetric. Yes, the zero matrix is symmetric or skew symmetric. I've told you that zero matrix is a symmetric matrix. Fine. That was logical also. Now I'm telling you the zero matrix is skew symmetric. So zero matrix is a special case which is both skew symmetric as well as symmetric. So it is not possible for any matrix to be both except the zero matrix. So a matrix could be either symmetric or skew symmetric. There is no such possibility that the matrix are both. So that is the exception. That is zero matrix has the exception. Now, if A is a square matrix, then A minus A transpose is a skew symmetric matrix. Okay. So I've told you, like A is a square matrix, then what is A plus A transpose? A plus A transpose is supposed to be symmetric, but A minus A transpose will be skew symmetric. Okay. And if A is a skew symmetric matrix, then Ka will also be skew symmetric. Same properties are there. Just a minor difference of this property is here. Okay. If A is skew symmetric, then A raised to power, okay, very important point. This is very important point. Like A raised to the power n will be, it will depend. Like it will be symmetric or skew symmetric. So you have to check for n. If n is even, then it will be symmetric, and if n is odd, then it will be skew symmetric. Okay, so you can like use this fact also. Minus raised to the power even is always plus. Minus raised to the power odd is always minus. So in case of minus you are getting that means you are getting skew symmetric. So this is the reason. So just note down all the properties. Okay. So every square matrix can be uniquely expressed as a sum of symmetric and skew symmetric matrices. Okay. So guys, there is this point that you have to note down. There will be definitely a question which is going to come on this property. Okay, because it is a standard question from board sample paper. See, so I'll write also 12th CBSE. Okay, so 12th CBSE, one question is definitely like it is going to appear from this. So the question will be like, express the matrix in the form of symmetric as well as a sum of symmetric and skew symmetric. So how do you do that? Suppose A matrix is given to you. Okay. And the question is asking like you have to express this matrix into the sum of two matrices such that one is among the two of them, one is symmetric and the other one is skew symmetric. You have to express A is equals to P plus Q, where this should be symmetric and this should be skew symmetric. Okay, so how we are going to express this? We have formulas for that. So in such a case, P will be equals to this and Q will be equals to this. Like if somewhere this question appears, if the question is saying that there is this matrix which is equals to A and you have to express this in the form of in the sum of two matrices such that one is among them one is symmetric and one is skew symmetric, then what you have to do? You just have to apply the formula. Now how do you apply the formula? A matrix will be given to you by the question. You have to take the transpose of that first. Now what you have to do? Add just add the two matrices. So A plus A transpose will be there. And now take the half. So whatever the result, that is going to be called as P, and again then you take the difference of two matrices and then again half it. So that will be give you the Q. So eventually ultimately the P will be symmetric only and Q will be skew symmetric only. Okay, so guys, I'm going to give you a question and you have to try it on your own. Express express A as the sum of symmetric and skew symmetric matrices, and A is this. Five, 0, 3, 2, 1, 4, 1, 4, 2. So guys, this is the question. Answer this and let me know the answer. Try this and let me know. Has anybody got the answer? Everybody is still doing it? Okay. Okay, students. Just look at the solution. Okay, I'm telling you how this is going to be done. Okay, so what was the first step? The first step was you have to find A transpose. So what will be A transpose? If A is this, what you have to do, you just have to interchange the rows and columns. So it will be 503, again 214 and 142. So this is transpose. Okay. Now second step is find A plus A transpose, or directly find half of A plus A transpose. So this is going to be your P. Okay. So I'll find A plus A transpose. So A plus A transpose will be 5 plus 5, it will be 10. 0 plus 2, it will be 2. And 3 plus 1, it will be 4. 2 plus 0, it will be 2. 1 plus 1, it will be 2. And 4 plus 4, it will be 8. 1 plus 3, it will be 4. 4 plus 4, it will be 8. And 2 plus 2, it will be 4. So this is my A plus A transpose. And I have to multiply it by half. So I have to divide each element by 2. So it will be 5, 1, 2, 1, 1, 4, 2, 4, 2. Okay, like this. Wait. Yes. So this is the P matrix. Now similarly you have to find Q matrix, which is half of A minus A transpose. So I can find the value of A minus A transpose, that is supposed to be 0. 0 minus 2, it will be minus 2. 3 minus 1, it will be 2. 2 minus 0, it will be 2. 1 minus 1, it will be again 0. 4 minus 4, it will be 0. 1 minus 1, it will be, sorry, 1 minus 3, it will be minus 2. And 4 minus 4, it will be 0. And 2 minus 2, it will be 0. Okay. So now if I just take the half, one second. Yeah. So if I just take the half, so it will be what? So I'll do that here. Like if I take the half, so it will be 0, minus 1, 1, 1, 0, 0, and minus 1, 0, 0. So now this is my P and this is my Q. So first we'll check like whether P, the value of P that we have got, sir, the result is same as A matrix. Yes, it is obviously going to be the same matrix now, because I have told you to do this, to do that. Like I have told you to express A as the sum of P and Q. You don't have to add P and Q. The finding P and Q is the only answer. You have to stop, because eventually P and Q will be added to get A now. So we'll check, like if we'll check two things. First of all, P should be symmetric and Q should be skew symmetric. And second, the addition of P and Q must be A. So we'll check that, like P is symmetric or not. So if I just randomly put any element, like 1. So A12 is 1. So A21 is also 1. Okay, with some other ring. I'll check A13, that is 2. A31 is also 2. Now I'll check A23, it is 4. A32 is also 4. So as you can say that P is symmetric. Yes. And if we talk about Q, so Q should be skew symmetric. So Q is skew symmetric. Yes, it is skew symmetric. We can see this is minus 1, so this is also, this is 1, 2, right? So 2 1 is also 2 1 is 1. Yes, so A12 is equal to minus of A21. Similarly, we can see that Q is also skew symmetric. Now there is second thing that we have to check, like P and Q must add to A. So what is P and Q? 5 plus 0 is what? 5 only. So 5 is the element that we got in A. Yes? No, this is not A. A is somewhere here. Yes. See, we have the first element as 5. Just pick any random element. 4 and 0. So 4. Yes, we have 4 over here. So this is the answer. So the answer is finally A can be expressed in the form of P and P plus Q, where P is your this matrix and Q is your this matrix. So in that question, what is the motive of that question? You have to find the values of P and Q, and then you have to stop. Okay. So this is going to be the answer. And this is a question from CBSE board. Each and every year this question appears. Everybody has noted it down. Everybody has copied this. Fine. Okay, so students, we'll take a short break, okay, of 10 minutes, and the class will resume at 8:10. So be there, okay? Because in the after that break, I'll be giving you some questions which are from JEE Mains. Okay, based on this thing. Fine. Okay, everyone, just turn on your cameras. The class is resumed. All of you quickly turn on your cameras. Okay, so we will do some very basic conceptual questions from this. Okay, like this is the question. Like, are you guys able to see it on your screen? So you have to find A transpose and then you have to take the transpose again. So I've told you this property now, like A transpose, the transpose of A transpose is always equals to A. Yes. So there is no need to do that question because answer is going to be same. Because if you will take the transpose, then A transpose will be there, and then you are going to take again the transpose. So I told you that A transpose, the transpose of A transpose will be A only. So there is no need to do that question. But yes, I don't know how it appeared sometimes in any competitive exam. So that is why we are having this question here. Okay. So this is very important to know that if you are having a good hold on properties now, there is no need to solve each and every question. You can just eliminate it by using brain. Everybody please turn on your cameras. We are back. And now we are going to cover so many questions as possible. Okay. Next question. Find A, B, and C if this is a symmetric matrix. So I know the condition for symmetric matrix. Yes. What is the condition for a symmetric matrix? That Aij is always going to equal for Aji. So I'll pick any random element that is 3 by 5. So A12 I have picked. That is 3 by 5. So what is A21? That is supposed to be equal to A21. Now what is A21 with B? A21 is B. So it gives me that B is equal to 3 by 5. Like if the question is saying that this matrix is a symmetric matrix, you can easily find the A, B and C just by comparing these values. Okay. Now A13 is equals to A31. This I already know. Why? Because this is mentioned in the question that this matrix is a symmetric matrix. What is A13? It is A. What is A31? It is minus 5. So I can write A as equals to minus 5. Now again I know that A12, no, A23 will be equal to A32. Yes. So A23 is what? Minus 5. Second row, and sorry, it is not minus 5, it is minus 7. Minus 7 is equal to A32. What is A32? Third row and second column, C. See, we have all the values A, B and C. So just by comparing the elements, we have got the answer. Very simple question. Fine. So these are the some questions which are building your concept. Okay. So in this session only, we are having some questions which are from JEE Mains also. We'll be approaching to that questions, but before that, we just have a good command of these questions also. Okay. Fine. Just let me know the answer, please. This is exactly the same question that we have discussed now. The only difference is that in that question it was symmetric matrix. Now in this question it is skew symmetric matrix. Find x comma y comma z if this is a skew symmetric matrix. So I know the conditions that A12 is always going to be equal to minus A21, and second condition will be A13 will be equal to minus of A31, and A23 is equals to minus of A32. Yes, A12 is what? First row, second column is minus 5i. Is equals to minus of A21. 21 is second row, first column. It is y. So minus y. So that gives me y is equals to 5i. So y we have evaluated. A13. First row, third column is x. Is equals to minus A31. 31 is 3 by 2. So x we have got minus 3 by 2. Now A23, second row, third column, it is again x. So x to we have now. For example, like this is a typing mistake. Suppose we call it as z. So what is minus A32? Third row, second column, it is minus of minus root 2. So that is z is equals to root 2. This is not x, this is z. Yes? Yes? Okay. Find K if following matrices are similar. Find K if following matrices are similar. I think this question is wrong. I don't have any idea like about this question, so this might be some typing mistake, so we can skip this question. Okay. Again, class, pay attention over here. It is very important. Classify the following matrix as singular or non-singular. Okay, singular or non-singular. So I am telling you the definition of singular matrix. This question has been appeared in like 12 CBSE board many times. So this is very important concept, like what are singular matrices? So singular matrices are those matrices. Singular matrices are those matrices which have their determinant equal to 0. Now what is this new term that we are having? Determinant. Fine. So that if A matrix is there, how to know like it is singular or not? You just find mod A. Now what does this mod A means? Mod A means determinant of A. So I'll completely tell you how to what is determinant first of all and how to find the value of determinant. Fine, that's not an issue. But this is condition which is very important. Like mod A is there, that is called as determinant of A. So what are singular matrices? Singular matrices are those matrices which have their determinant equal to 0. Like if a matrix is given to you, what you have to do? You just have to find the value of determinant. And then if that value is equals to 0, the matrix is singular, else it is not. So is this thing clear to you? Is this thing clear to you? Yes. Now, my question, how many of you are able to find the determinant of a matrix? How many people know how to find the determinant? Okay, Saga Murugan, you know, Shrutika, you know, Sudarshan, you know. Fine. So rest of the people don't know? Jyotsna, no, Kritika, no. Okay, I guess like 50% of the class knows how to find the value of determinant. Fine. So there is a discussion on determinant in the next session also. But yes, just because we have singular and non-singular matrices over here, so that means there is a need to discuss determinant. Fine. So what are singular matrix? If the determinant, if the matrix, if the determinant for that matrix is 0, then it is called as singular matrix. So the students that are raising their hands, can you please tell me like this matrix is singular or non-singular? You have to try this question. This matrix is given to you. You just have to let me know it is singular or non-singular. For that, you have to obviously find the determinant of this matrix. Please go ahead. And everybody just turn on your cameras. Muthukumaran, Jyotsna, Sagamurgan, Kayal, Dhaneshwar, Sastita, Sai, Trivikram, and Adil. Has anybody got the answer? Those who know how to find the determinant, just evaluate the determinant for that matrix, and if it is 0, then it is singular. How much time it is going to take for you guys? I'll give 2 more minutes for that question, else I'll proceed. Has anybody got the answer? Uh, Trivikram, you are finding the value of determinant, right? So have you got the answer? Okay, just try. Adil, have you got the value? Okay, try. Josna, have you got the value? Not now. And Kritika? Not now. Okay. Fine. Class, can we do this thing? Like, what if we just skip this question? Because this is from determinant, so we can bring it in next session also. So meanwhile, we can practice the questions that are actually from this session. Is it okay for you guys? Fine. Because there are some questions which are directly from JEE Mains. Okay, so we should practice that first. Okay. Fine. We are skipping this question now. So show that the following matrix is a singular matrix. Again, skip. Okay. Now this is very easy basic question. A is this and B is this. 2A minus 3B you have to find. I am sure you are able to find 2A minus 3B. Okay. So how we are going to do that? So what is non-singular matrix? Non-singular matrix whose determinant is not equal to 0. Simply. Like every matrix is non-singular matrix only. But yes, if it is having its determinant as equals to 0, then it is singular. Okay, yes. Okay, in this case, you have to find 2A. So how do you find 2A? So it is 10, it is minus 6, it is 2, it is 0, it will be minus 8, and it will be minus 4. So 2a is this. What we have done, we have just multiplied each and every element with 2. There is nothing new in this concept. Again, I have to find 3b now. So what will be 3b? 3b will be, now I have to multiply each and every element in b with 3. So it is 6, 21, minus 9, 3, 6, and minus 6. Now if somebody asks me what is 2a minus 3b, so what I am going to do is I just take the difference of these two matrices obtained. So 10 minus 6, it is 4. Minus 6 minus 21, it is minus 27. 2 minus minus 9, it is 2 plus 9, that is 11. 0 minus 3, it is minus 3. Minus 8 minus 6, it is minus 14. And minus 4 minus minus 6, that is minus 4 plus 6, that is 2. This is the answer for 2a minus 3b. Very easy question. Yes or no? Okay. Speed really matters in such kind of cases. So you have to like get a good command in calculation. Okay. Again, we are not reached up to that level. This question is again from CBSE. What if p plus q is this and p minus 2q is this? You have to find the value of p and q. So I know that p plus q is 2 minus 1, 1, 3, and minus 3 and minus 2. Yes. And second is p minus 2q. P minus 2q is, so we have another matrix that is minus 2, 1, 3 minus 1, 4 minus 2. And the question is asking what is the value of p and q. What are the values of p and q? So I can do one thing. I can just subtract these two matrices. Yes or no? I can just subtract these matrices. So this p and p will eliminate itself, and q minus minus 2q will be q plus 2q, that will be 3q. Okay. So but if I am subtracting something on the left hand side, then I have to subtract the same thing, do the same thing on the right hand side also. So this brings me to that 3q will be equal to what? Difference of these two matrices. Yes. So 2 minus minus 2 will be 4. Minus 1 will be minus 2. 1 minus 3, 3 minus minus 1 will be 4. Minus 3 minus 4 will be minus 7. Minus 2 plus 2, 0. Yes. So if 3q is this, then you can easily find q. So just divide each and every element by 3. So it is 4 by 3, minus 2 by 3, minus 2 by 3, 4 by 3, minus 7 by 3, and again 0. So this is the value of q. Got it? See, you are having two equations now. P plus q is equal to something and p minus 2q is equal to something. So let us suppose this is my equation 1 and this is my equation 2. So what I have done is I just subtracted the equation 1 and 2. When I do the subtraction, this p and p will eliminate itself. So it will become q minus minus 2q, that is q plus 2q. That will be eventually 3q. And also whatever I am doing on the left hand side, that will be same thing I have to perform on the right hand side. So once I do that, so 3q will be this. So in the same fashion I have obtained q. Not just because I have q. So I know that p plus q is this matrix. Yes. So I can easily find p also using q minus this matrix. I know that p will be what? P is q minus this matrix, that is 2 minus 1, 1, 3 and minus 3 and minus 2. So I can find the q already I am having with me. So I can do the calculation and find the value of p also. Yes, this question is also clear to you? Everybody, this question is clear? Do you want to copy it? Okay, 1 minute I am giving. Just note it down and then we'll jump to the question. Okay guys, there is one announcement also. Like you are having this lecture with me, that is operation on matrices. Okay, so we have, I guess, one more lecture on matrices, and after that we will start determinants, and we'll have two lectures in determinants also. Okay, and after that DRS of this chapter will be there, like doubt removal session of matrices and determinant will be there obviously. Okay, so there is a possibility, I am not sure right now, but yes, there is a possibility that some new faculty would be joining with us. Okay, so it is not necessary that she is going to take lectures. I will take the lectures, but yes, we can also assign some batches, some lectures to her also. Okay, so after once this determinant is over, so the next chapter we are having as continuity and differentiability. Okay, but in order to learn continuity and differentiability, we have to go through the concept of limits first. So limits is something which is not in class 12th, but yes, it was there in class 11th, and it is very important, the foundation chapter of calculus. So I'll make sure that I'll deliver that session, but if it is not like we'll see like how we are going to manage this thing. Okay, so just I'm here just announcing that there is a possibility that there might be some chances that some new faculty would be taking your classes from next to next session or to for next chapter, like whatever it is. Okay, yeah, so don't get surprised if someday she randomly appears. Okay, and that is also not the thing that like I'll be not there, I'll be also here. Okay, I'll also be taking sessions, so don't worry. Okay, fine. So the next question. Again, we have a question from CBSE. Let's check how many questions we are having from CBSE. Okay, there are so many questions from CBSE. And then, fine. See, this question is from JEE Mains. Okay. This question is from Mains. Anybody want to give it a try? You want to give it a try or you want me to solve this question? See, we'll go backward also, okay? Because we have skipped so many questions. Question. Yes, now because question is here, so we'll solve this question first, but then we'll go backwards. The questions that we have skipped, some of the questions we'll be doing. Not every, but yes, some of the questions. So you guys let me know first, like, do you want to give it a try or you want me to solve that question? Just raise your hands who are willing it to give it a try. Fine. So please try. Okay. So please try, and I'm giving you a 2-minute window for that. Okay. After 2 minutes, I'll be discussing the solution with you. What is this TR stands for? TR of X. Anybody please put that in chat for me. What is this TR? TR is supposed to be known as trace of matrix. I have clearly told you guys that trace of matrix we are going to represent it using TR. I think the guys who are not knowing it must have missed that session, but that's not an issue. Sudarshan, transpose is transpose is something else. Okay, like A transpose is this is the representation of transpose. I'll not write TR of X now. TR of X is known as trace of matrix. Now what do you do in this trace? Trace is sum of diagonal elements. Okay, like if you are having any matrix which is like 1 2 3 0 0 0 0 0 0, like this you are having, so you just have to take the diagonal sum. Like what are the elements in the diagonal? That is 1 plus 2, 1 2 and 3, just add them. So 3 plus 2 plus 1 is 6. So this is known as trace of matrix. So yes, this is a concept which is in CBSE, which is not in CBSE, which is in only JEE Mains, and that I've clearly told you guys in the first session. So the one who are having no idea, just note it down somewhere else. Okay, what do you mean by trace of matrix? It is known as the sum of the elements present in the principal diagonal, and it is represented by using TR. Transpose is something else. Okay guys, so now I am telling how we are going to solve this question. Please pay maximum attention, and before that everybody just turn on your cameras. Yeah, pay attention over here, this one is very important. Also very good question. Okay, so I'll first adjust this question somewhere here. Okay, I'll erase this because it is using so much space. Yes. So the question is visible, everybody? Fine. Now we can say, we can see that in this question we are having with three matrices. X is given to us, Y is given to us, and Z is given to us. Okay. Find the value of sum of trace of X plus trace of XYZ over 2. Okay, that means we have to find the matrix X, Y, Z, and then we have to divide it by 2, and whatever is there we have to find the trace. Okay, and then again I have to find X, Y, Z whole square. Like I have to find YZ matrix first, then I have to square it, then I have to multiply it by X, then I have to divide it by 4, and then I have to find the trace for that. Okay, this is the thing that is mentioned now. And this process I have to repeat infinite times. Do you think this is going to happen really for this question? No. So what my mind says is, like in this question, I can clearly see that this is something which is not up to the mark, because this is not the way to solve such kind of questions. But yes, I can observe a pattern. Like XYZ over 2 is there. Another term is XYZ square over 4. The square is only assigned to yz, not entire xyz. Because in the next term it is x yz to the power 4 over, 3 over 8. Yes. So it means there is some relation between y and z, because only these two matrices are clubbed. Yes. So ignore everything, just find yz. So now I'll find yz first. I'll delete this also, delete this also. Yes. So my practice is to find yz first. Okay. So y is 5, 4, 6, 5. And z is 5, minus 4, minus 6 and 5. So yes, this is of 2 cross 2. This is of 2 cross 2. So I can clearly see that 2 cross 2, the multiplication is possible and the product only. So yz will be this. Now first row, first column. So 5 into 5 plus 4 into minus 6. So that is 1. You all are like able to perform multiplication now, because this we are discussing from past one hour. Okay. So this is 1. Now A12 will be first row but second column. So 5 into minus 4 plus 4 into 5. Oh, it is 0, because it is minus 20 plus 20. Again this one. So 2, 1 will be first row and second column. Sorry. Second row and first column. So 6 into 5 and 5 into minus 6. Again it is 0. And if I have asked 2, 2, so it will be second row and second column. So 6 into minus 1 is minus 24. But 5 into 5 is 25. It is plus 1. So here I've got that yz is nothing but I2. So what is this I2? I2 is identity matrix. Identity matrix of order 2. So now if somewhere yz is written, I can simply write it as 1. Why? Because yz is a matrix, which is an identity matrix, which is equivalent to 1. So why I'll write 1? Okay. So while in place of yz, I'll be writing 1, because I know that yz is identity matrix. Identity matrix means nothing is written, only 1 is written. So now my expression becomes trace of x plus trace of x by 2. Yes, because I'll be eliminating yz and replacing it by 1 plus trace of x by 4. Because it is x yz square by 4, but I know yz is 1. If yz is 1, so 1 raised to the power 2 is also 1. So I will eliminate yz from the entire expression. So the next term will become trace of it is x by 8, and till infinity it is going. Students, just tell me, is this step is clear to you? Why we are eliminating yz as 1? Why we are replacing the yz by 1? Because yz is an identity matrix. And identity matrix is nothing but just 1. 1 written in the form of matrix. That's all. Okay? Yes. So now the question is not completed yet. Now there was this property in trace of matrix. When I told you the trace of matrices, I also told you that, see, if x by 2 is there, okay, you have to find trace of x by 2. So you can find trace of x only, and then you can divide entire number by 1 by 2. Okay, this is the property. So this will save your time. Like this, you don't have to calculate a new matrix. Like you are already having x matrix with you now, so you don't have to calculate x by 2, x by 4, x by 8. So what happens is, you can write this as trace of x plus this can be written as 1 by 2 times trace of x. This can be written 1 by 4 times trace of x. This can be written 1 by 8 times trace of x till infinity. Now I can clearly take trace of x as common. So this will brings me to, so when I take trace of x to be common, so it will become 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus infinity. Now this is something which is very familiar to me. This is a GP. This is a decreasing GP. This is nothing but a decreasing GP. Now what are the sum of infinite terms of GP? I know this formula. Sum of infinity is what? A over 1 minus R. So here A is 1 and R is 1 by 2. So 1 over 1 minus 1 by 2. That is 1 over 1 by 2. That is 2 only. So I got my answer as trace of x times 2. Now what is trace of x? Now I have x matrix also. So I can see the x matrix, that is this 2 1 4 1. So what is the trace of x? So trace of x will be sum of diagonals, right? Sum of elements present in the diagonal. So 2 plus 1, that is 3. Now what is final answer? 3 multiplied by 2. So 3 multiplied by 2, that is 6. So 6 is supposed to be the final answer for that. So A is the correct option. So I'll put that in a proper placement, okay, and then you can copy the whole question. Is it visible, students? This much is visible to you, or should I enlarge it? If it is visible, just give me a thumbs up. Okay, fine. So note it down quickly, and then we'll be doing some other questions. Yes, you have copied the question, everybody? Okay. So we will do some next question. Okay. So class, I am giving you this question. Okay. Just solve this one and let me know. What is the value of C21? You have to find the value of C21 in this question. Okay. Everyone, do try this. Has anybody got the answer? See, again, I'll tell you, you don't have to find the entire matrix. Okay. C21 means the element which is present in second row and first column of the C matrix. So don't find C matrix, just find that particular element only. C21 is equals to 22. Okay, let me check. So C21 means what? That means second row and first column. right? This is only C21, second row and first column. So 0 into minus 1 plus 1 into 2 plus 4 into 5. Okay, so this is 2 only and this is 20 only. But this will be 0. So what is 2 plus 20? It is 22. So yes, everybody that has got 22 as an answer, it is correct. Okay. Okay. So now this question I'm giving to you, and you have to find this. This is also very important for CBSE. If P matrix is 3 minus 2, 4 minus 2, find K so that P square minus KP plus 2I is equals to 0, where I is an identity matrix and O is a null matrix of order 2. Okay? O is a null matrix means what? It is 0 only. So you have to find P square first. Okay? So P matrix is already given to you. You have to find P square first. That will be P into P. Just don't square each and every element. Okay? This is not the proper way. You have to multiply P with P. So 3 minus 2, 4 minus 2. Again multiplied by 3 minus 2, 4 minus 2. So this will be your P square. What is KP? We don't know. But yes, KP will be what? K will be multiplied to each and every element in P. So that will be 3K minus 2K, 4K and minus 2K. Yes? Yes. This is your KP. And what will be the value of 2I? So 2I will be, see, I we know that it is 1010. Yes. So it will be 2, 2, 0 and 0. Now according to this question, all the three terms will add up to 0. So this you have to do it on your own. I just have like assisted you in this question. Okay. So let me know the final answer quickly. Okay guys. So I've assigned 2 tests to all of you. So please go and check your respective dashboards. Okay. So you have to go through the class assessment test and you have to attempt the test right now. And after 10 to 15 minutes, I'll be discussing the answers with you. Okay. So just go and attempt those tests and let me know if the test is visible to you or not. Everybody. C and SW both are visible, sir. Fine. So just go everyone and attempt those tests and I'll be discussing that in 15 minutes. Okay? Okay, okay. Sir, I can see only one test. Okay, Trivikram, can you please refresh your dashboard and check once again? Just refresh and check this once again, okay? Because I have assigned both the tests. Okay. Okay, so that's not an issue. So just go through the class assessment test, okay? And I'll ask my backend team to fix this. Okay. Okay, everyone. We have one more question from this. See, so just hold it for a second, okay? I'm sure you guys have attempting that class assessment test, okay? But there is one more question, so I have to discuss that, and after that you can resume with your class assessment, okay? So this is this question like a matrix is given to you, that is A, which is equals to cos theta, I sin theta, and cos theta. Here theta has been mentioned as pi by 24, okay? And a raised to the power 5 is ABCD. That clearly means we have to find the value of a raised to the power 5, and then we will compare the elements with A, B, C and D. Now I'll tell you, whenever this kind of matrix appears now, so this is a special case of matrix. Like you don't have to do a square is equals to a into a. You don't have to do a cube is equals to a into a into a. Okay. Generally, this is the ideal method to find the value of a square and a cube, but in this case, there is no need to do so. So this is a trick that I would like to share with all of you. If a is cos theta, I sin theta, only for this matrix I'm telling you, I sin theta and cos theta, then a square, a cube and a4 and a5 can be directly written as, okay? So a square will be what? Just replace your theta with 2 theta. A cube will be what? Just replace your theta with 3 theta. A4 will be what? Just replace your theta with 4 theta. And similarly, what we have? We have to find A5. So I'll not multiply it 5 times. Rather, I will replace my theta to be 5 theta. So this brings me to a raised to the power 5 will equal to cos 5 theta, I sin 5 theta, I sin 5 theta again, and cos 5 theta again. Okay. Now this is A, B, C and D. This is equals to A, B and C, D. As I've given that a raised to the power 5 is A, B, C, D. Okay. So I can clearly tell that A is equal to cos 5 theta. A is equal to cos 5 theta. B is equals to I sin 5 theta. Okay. So this much information I have gathered. Okay. Now which of the following is not true? Which of the following is not true? So we can try option elimination over here. Okay. So we can find the value of a square minus b square. We can find the value of a square minus b square. We can find the value of a square minus c square. Okay. So let's start with a square minus b square. So I know that a is what? It is cos square 5 theta. And d square is what? D is also my cos 5 theta, right? D is also my cos 5 theta. So a square minus b square is what? Yes, it will be 0. So that means this statement is true. But this is not going to be our answer because the question says which of the following is not true. Yes? Now I will find a square minus b square. So a square minus b square is what? That is cos square 5 theta minus I square sin square 5 theta. Now I know that minus I square is plus 1. So it will be cos square 5 theta plus sin square 5 theta. That is equals to 1. So this statement is also true. A square minus b square is also equals to 1. So both the statements are true. Okay. Now I will check a square minus c square. So a square minus c square will be what? So a square minus c square will be 1 only, na? Because a is cos 5 theta and c is I sin 5 theta. Again, I have calculated a square minus c square, so it will be what? It will be 1. So all the three statements are correct. So that means this is eventually the wrong one. I don't know, like what is the value of a square plus b square. It could be it should be lying between 0 or 1. I don't know. But I don't have to check for it also. Why? Because I can clearly see that three options are correct. So if three options are correct, the fourth one is eventually supposed to be wrong. So I hope this much is clear. I hope this question is clear to everyone.